Welcome to the unit on NumPy. In this unit, we're going to be talking about this really powerful Python package called NumPy, which is really popular with the data science community. The power of NumPy is because it allows vectorized data representation. It allows you to represent data in form of vectors and matrices and perform operations in terms of vectors and matrices. It allows you to represent data in form of vectors and matrices and allows you to perform operations on these vectors and matrices. This is a really intuitive way of representing data and a really popular way. So that is why NumPy is really powerful. For the purpose of this unit, we would be using NumPy, which is shipped with the Canopy IDE, or the Canopy Express IDE, interacting with it through the IPython console. Uh, but if you wish to download NumPy for yourself and you're not going to be using the Canopy ID, you can do that from this page. From the link to this page would be provided in the resources file which is provided, so you can get NumPy for your version of Python and your operating system and work with it. But as I said, for the purpose of this course, we're going to be using NumPy with Canopy or interacting with it through IPython. So let's get started with NumPy. In order to use anything from NumPy, you would have to import the NumPy package. Okay, now importing the NumPy package as NP is a standard convention followed in the data science community. So this is how we're going to be doing it now, and this is how we're going to be doing it for the remainder of the course. So as the import is successful, it indicates that NumPy is properly installed. So we can start playing with NumPy. An ND array, or an n-dimensional array, is the basic data structure in NumPy which allows all the vectorized representation and all the cool stuff. So let's get started by uh, creating an ND array. So the array method is used to create an ND array. To this method, you would pass a list of elements. Now this would create, okay, so this would create an ND array with 4 elements. If you want to create a more complex array like a two-dimensional array, you can use the same array method and pass to it a list of rows where each row would be the elements. So basically it is a list of elements. So in this outer list you would have the each element would be a row, and in the inner list each element would be the individual element. So let's say, so this would create a 3 by 3 matrix. Let's look at some of the attributes of this matrix. So if you want to find the dimensionality of the ND array, you can use the ndim property. As the array we created was a 3 by 3 array, that is, the dimensionality was 2. So that is what is said or stored in the ndim property. You could you could check the shape of the array by using the shape property. This says that it was a 3 by 3 array. You could check the size of the array by using the size property. The size is essentially the product of the elements in the shape. So since our array was a 3 by 3 array, we get 3 by 3, or 3 times 3 equal to 9. The dtype property can be used to check the data type. So since all the elements were int, this is an int 32 data type. Okay. There are other int data types as like the int 8, int 16, int 32, and there are float and double data types. There are boolean data types. So the dtype can be used to check the data type of the array. Also, there is a really important method called the reshape method, which can be used to reshape the array. So let's say d equal to reshape. Then to this method you would pass a tuple. You do not pass the shape directly, you pass it as a tuple. So let's say I want 9 rows in one column. So now D has 9 rows and one column. However, the reshape method does not alter the actual array. So if I still print S, it is still a 3 by 3 array. So the reshape method would create a copy and change the dimensionality or change the shape of that copy, and it does not alter the actual array. Now let us look at some popular ways of creating arrays. If you want an array with all zeros, you can use the zeros method. Say I call the zeros method and pass to it the integer 5. It would create an array with 5 elements, all of them being zeros. If I want a higher dimensional array, I would pass to it a tuple. So this would create an array with all zeros, with the array being a 2 by 2 array. So this is a 2 by 2 array. If instead of calling the zeros method, I call the ones method, it would create an array where all elements are 1, and the dimensional and the size would be according to the size passed in the argument. So this would be a 2 by 2 array with all elements being 1s. Uh, Now we would also look at two other methods, that is the arange method and the linspace method. If you call the arange method and pass to it the start, the end, and the step size, it would create an array which starts at the start, ends right before the end. So you would see that 11 is not included. uh, that is because the arange method does not include the end, and the step size is 2. You can see that it is 1 to 3, so the step size is 2, and 3 to 5, again the step size is 2. uh, you can omit the step size, and a default step size of 1 is taken. So this starts from 1 and ends at 10, which is the integer right before 11. uh, and if you omit the start, it would uh, take the start to be a default of 0. So here the array starts from 0. The linspace method uh, takes the start, end, and the number of elements in the array. So let's say 1, 10, and I want 10 elements in the array. So this would create an array which starts at the start, ends at end. Here you would see that 10 is included. This is different from arange where 11 was not included in the last case, but in here the end element is included and the array has a total of 10 elements. We can see that there are 10 elements from 1 to 10. So this method creates an array with start, end, and the number of elements is specified. If you do not specify the number of elements, the default of 50 is taken. So this array has 50 elements. You can see that there are 50 elements in this array. I mean, you can try it out. Let's look at the arithmetic operations or the arithmetic operators in a NumPy. Let's have two arrays, A and B, where this is A and this is B. So A is essentially 2, 3, 3, 4, 2 by 2 array, and B is again a 2 by 2 array, 1, 2, 2, 3. Now I can do A plus B, which would yield an element-wise addition. So basically each element is added to the corresponding element. I can do A minus B, which is an element-wise subtraction. I can do A times B, which is an element-wise product. Uh, this is different from a dot product, which can be obtained by A dot B. So this is essentially a dot product. A dot product is a linear is a function in linear algebra, which is different from element-wise product. So A times B would be an element-wise product, and A dot B would be a dot product, and A divided by B would be a divided by b, as in the division. So here you can see that there are no floating point precision. This is because all the elements were int. If you had float numbers or double numbers, you would get float precision. So this is a property in Python. If all numbers are int, the results would be int. You could also so let's look at a again. So if this is a, you could also do a plus 2. So this would add 2 to all elements in a. So the difference between a plus b and a plus 2 is that 2 is a scalar, where while b was a matrix. I could also do a minus 2. It would subtract 2 from all elements in a. I could do a times 2. It would multiply each element in a by 2. I could do a divided by 2. So now this would yield uh, division without the floating point position. However, if I did a divided by 2.0, now as 2.0 is a float point number, I would get floating point precision. So also I could do a double asterisk 2. So now this would raise the power of all the elements in a to 2. So this would be a to the 2 essentially. So so this is a. So it is 2 3 3 4, whereas a to the 2 is 4 9 9 16. So these are basically the operations which are possible using uh, Numpy. So you can directly add, subtract by the plus minus operators.